We present chemistry for Form 3. This is Program 1 of Term 2. Our strand is sulfur and its compound, and our substrand is properties of sulfuric 6 acid. During this program, you are advised to take short notes.
Hello Form 3 learners, I'm Teacher Utieni. In our today's class, we are going to discuss about the properties of concentrated sulfuric 6 acid. With me in the class today, we have Form 3 learners. I'll allow them to introduce themselves.
Hello learners, my name is Carlos Ogmar.
Hello learners, my name is Shadrach Makori.
Hello learners, my name is Ibn Kelvin.
Now learners, who can drink acid? If you are given acid today, who can drink it? Kelvin can? Makori? Ibn? Yes? Can. You can't. Makori? Why can't you drink it? Why can't you drink it? If you are given an acid, why can't you drink it? Yes, Makori?
Stomach.
Yeah? Yes, it's corrosive. That is why you can't drink it. Very nice. Now our strand here is on sulfur. And our substrand is on the properties. Of concentrated our substrate is the properties of concentrated sulfuric 6 acid. Our first property that we are going to discuss about, the first property that we are going to discuss about is that sulfuric 6 acid, it's colorless, oily, liquid. Now you know very well that sulfuric 6 acid, we use it in our car batteries, those batteries that are used in the cars. We have sulfuric 6 acid, and there you can observe that it's a colorless oil. I believe you know what I mean with the term oil. Someone to tell us what oil, this manner, this is oil. Yes, Makori?
It's viscous.
Yeah, it's a bit viscous. Have you taken a class? Yes. Yeah? And the second property number 2, is that sulfuric 6 acid, it is a soluble acid that when you add it to water, it dissolves completely. Okay? When you add sulfuric 6 acid to water, it dissolves completely. Remember, when you're diluting an acid, you add the acid to water. You don't add water to acid. Put together. Yes. The that property, we have sulfuric 6 acid. It has three hydrogen ions. Three hydrogen ions. This indicates that the acid is what in nature is what the acid is acidic in nature. When, how can you confirm that it is acidic in nature? Yes,
You can test it using indicators, universal indicators.
Yes. Universal indicator is what?
Let's say maybe a solution of sulfuric acid is when a really much vapor is immersed in a solution of containing sulfuric acid.
Yes.
It does indicate that the acid is acidic.
Yeah, we use a blue. Litmus paper, it turns from blue to red. Then this indicates that the solution is acidic in nature. Very well. We go to the next property, the fourth property, and the properties is on the hygroscopy. We say that sulfuric concentrated sulfuric acid is hygroscopic in nature. Hygroscopic in nature. It's hygroscopic in nature. Yes, someone to tell us what they understand the term hygroscopic. Yes, even this is a problem. Yeah, this is a drying agent. Very good. Very good. And when you say this is a drying agent, what can you dry this is the concentration of this acid? Or which substances can you dry using it? Yes, H4O.
Production of oxygen gas.
Yeah, you can use it in drying. It is used in drying. Oxygen gas, one oxygen. Oxygen gas, yes, another gas that you can dry using concentration of this acid. Yes, according
Hydrogen gas.
hydrogen gas, very good. Yes. Any other? Yeah, we also have nitrogen. Nitrogen gas. So these are some of the gases that we can write using concentrations of sulfuric acid. Yes, our next property that we're going to discuss, property number 5, is on the dehydrating. Dehydrating property. So someone to tell us what dehydrating is. Someone to tell us what dehydrating is. Yes, Marco.
Now, dehydrating means that the acid removes elements of water from the compound.
Yeah, very good. Very good. The acid is able to remove elements of water from a compound. Yeah. Let's give an example. Examples of elements of water. Yes, Kelvin.
We have hydrogen and oxygen.
Yeah, hydrogen and oxygen. Hydrogen and oxygen make water. That is why we write the symbols of water as H, H2O, the hydrogen and water. Now, this property of the dehydrating property, if you apply it on some substances, for example, sugar, we have ethanol. If you apply it, or if you apply sulfuric acid to those substances, then there is a compound that will remove water or eliminate water from the substance. Yeah. And a good example, one of the example, we have sugar. Sugar is the symbol. Yeah, this one, it will be so this is sugar. If you apply, if you put sugar in a container that has sulfuric acid, which is concentrated, the sugar will turn from brown, if this is brown, let's say it is brown. It turns from brown to carbon. Carbon is black in color. Brown to black. Brown to black. Are you together? Yes. Yeah, we get another example from you. Yes, Kevin. Yeah, when you have an organic acid, and you subject it to hydrogen, sulphuric acid, sorry. You get it up on the other side. And water. Yeah, that's love. Very good. Today, it's a nice example that when you have the organic acid, you subject to sulfuric acid, which is concentrated, you get the carbon monoxide or carbon dioxide and water. This is also a property that we use in the preparation of carbon dioxide back in carbon to carbon. Are we together? Anybody with a question to them? Yes, what?
Not a question, but what regulating property. Yes. The sulfuric acid can also be used I think industrial preparation of nitric 5 acid to remove the traces of water in order to get a 95 or more % of nitric 5 acid.
Yeah, very good. Second one. Any other? Somebody has anything to add? Yeah. Now we move to our next property, which is number 6, and that is sulfuric acid concentrated. It is a strong oxidizing agent. Sulfuric acid, which is concentrated, it is a strong oxidizing agent. Now, what do I mean by this? Yes, Macaulay?
Now, what I understand from that point, strong oxidizing agent, is that the acid is able to react to metals with the least reactive metals in the periodic table, not the least reactive metals in the reactivity series.
Very good, Macaulay. Now, can you name some of the examples of these reactive elements in the periodic table? Yes, Okoro.
Copper.
Yeah, we have copper, that's one. Another one, we have zinc. Very good. KBA, we have zinc. Zinc is another example. Yes, Macaulay?
We have iron.
Iron. We also have iron as one of the least reactive elements in the reactivity series. Are we together? Now, we can have an equation. You can write this one. You can write this one. We have copper. Copper is solid in nature and concentrated sulfuric acid. And if it's concentrated, the state symbol is liquid. Remember that one? Liquid. We get copper, sulfate plus sulfur 4 oxide gas plus water. Are we together? Are we together?
Yes.
Yeah, very good. We have copper plus sulfuric acid, which is concentrated. We get copper sulfate plus sulfur 4 oxide gas plus water. Are we together? Yeah, somebody to come and write for us the equation for iron and sulfuric acid. Iron and sulfuric acid. Yes, Macaulay?
Now, from that equation, you can write an equation of iron. It will be iron plus sulfuric acid
The product will be iron sulfate, iron sulfate, plus sulfur oxide, plus water.
Yeah, very good. Let's clap for him. Very nice story. That was a nice. Yes, so let's look at the last property of sulfuric acid. Property number 7. And that is that some concentrated sulfuric acid is a less volatile acid. It's a less volatile acid. When you hear the term less volatile, I want you to remember that when you are told that an acid is less volatile, it means that the acid it can displace more volatile acid from their source. Are you together? An example of a more volatile acid, yes? Yes, can you?
Hydrochloric acid.
Hydrochloric acid, very good. Another example of a more volatile acid. Yes, come on.
Nitric acid.
Nitric acid. Those two are more volatile acids, and we have encountered them in many occasions in our laboratory. Now we have an application of how that less volatile property can be exhibited, and a good example is that you can take a solid. You can take a solid of hydrochloric acid. An example is sodium chloride. When you add concentrated sulfuric acid, this one produces a more volatile acid, which is the more volatile acid, which is hydrochloric acid. Hydrochloric acid, hydrochloric acid. You will also have sodium, sulfate, and water. Okay, water is in liquid. This one is in aqueous state. And also this one is in aqueous state. Are we together?
Yes.
Very good. Any question until there? Any question? Yes? Anybody got a question? Okay, then if you don't have a question, I wish to summarize the lesson. What have you learned today? What have you learned today? Yes, correct.
Yes, we have learned about the properties of concentrated sulfuric acid, and we have the point. So one of it is that it's a less volatile acid. This means that sulfuric acid can displace more volatile acids in other compounds.
Very good. Yeah. Another thing that you have learned today. Yes, today.
It's hygroscopic in nature, meaning
Yes, what is that is hygroscopic in nature?
sulfuric acid.
Concentrated sulfuric acid. Remember, concentrated sulfuric acid. Very good. It is hygroscopic in nature. And what did he say that is? Who can tell us what the hygroscopic property of it was? Yes, Papa.
Concentrated sulfuric acid can be used to dry gases that do not react with the acid.
Yeah, very good. And we name some of the gases that can be used. Somebody tell us one that we name. First of all,
Oxygen gas.
oxygen gas. Very good. Another thing that you have done here. Yes, Kukuro.
The sulfuric acid is also a dehydrating agent. That means that it can remove elements of water from some elements.
Yeah, very good that it is a dehydrating agent. It can be used to remove elements of water from compounds. And you gave a good example of sugar. If you add sulfuric 6 acid to sugar, the sugar will turn from brown to black, indicating that water has been removed from it. Okay?
Yes.
Are we together? Yes, another example. Another thing that you have learned today. Yes, Makori?
That
Concentrated sulfuric 6 acid is a colorless oily liquid and it is used in car batteries.
Very good. Very good. So concentrated sulfuric 6 acid, it is a colorless oily liquid. And we say that we use them in car batteries. Yes, Kevin?
You have learned that sulfuric 6 acid is strong oxidizing agent since it oxidizes less reactive metals in reactivity series.
Very good. Very good. That sulfuric 6 acid is a strong oxidizing agent, and we saw an example. It is able to oxidize copper. Remember very well that dilute sulfuric 6 acid cannot react with copper because copper is below hydrogen in the reactivity series. And with that, I wish to give you an assignment. Since you have learned about the less volatile property of sulfuric 6 acid and you have used a salt of hydrochloric acid, now I want you to go home and write an equation of sodium nitrate plus sulfuric 6 acid and give us the product. The product, what will be formed. Are we together? Are we together? Yeah, very good. Very good. And with that, we have come to the end of our lesson today. Till we meet next time, goodbye.
You have been watching Program 1 of Term 2 in the Secondary Chemistry for Form 3. Our strand today was sulfur and our substrand was properties of concentrated sulfuric 6 acid. This program was written by Jason Kerosi, Carlos Okworo, Kelvin Kebenei, Austin Otieno, and Shadrach Makori. Your TV teacher was Austin Otieno, and your TV students were Kelvin Kebenei, Carlos Okworo, and Shadrach Makori. The technical operator was Jason Kerosi. This program was produced in conjunction with the Department of Education Communication Technology, Kenyatta University. Thank you.